Hello, everyone, and welcome to Amsterdam. Just kidding, I just got here. My name is Guillermo Rauch, and I'm the creator of a few Node.js frameworks that you might have used, Node.js libraries that you might have used, like Socket.io, Mongoose, and a few other smaller projects. If you're up to date with our latest work, you probably know about other stuff like Hyperterm or Micro, and you can probably later on see all of that at our new GitHub account. So I'm the CEO of a company called Zeit. We're creating this product called Now, which is the easiest way to deploy anything to the cloud. We call it real-time global deployments. And I'm going to talk about specifically what we mean by each of these things. First of all, let's start with deployment. What we mean by deployment is launching your application code and running it in the cloud. What's the cloud? So when I think about the cloud, it's funny because it's a term that has been said so many times that sometimes we forget specifically what we're talking about. And according to Larry Ellison, there's a really interesting interview that was done in 2008. The CEO of Oracle had a little bit of a struggle or a fight with this term. And there's a really funny interview where he says, he gets a little bit frustrated about this word. Like, what does cloud mean? He argues that they've been doing cloud for so many years, and that the cloud is just a network of computers connected to the internet. And that we've redefined the term to basically encompass everything that we do nowadays. And then there's something that's extra interesting, because in his attempt to fight this term, I think he actually provides a definition that he calls insane, but I think it's actually a really great thing to strive for. So he says that it's a computer that's out there. And the people who build this crap are out there. They're insane. And maybe so, because I think that the term cloud as an ideal thing to strive for is very fitting, because cloud doesn't mean a specific geographical location. It doesn't mean a specific proprietary solution. And clouds can be everywhere. And ideally, they're above every one of your users' heads, and they can access information and APIs and services with minimal latency. So that idea of the cloud, which is a computer that's out there, is a very, very good idea. But when most people talk about the cloud nowadays, they actually mean a very specific thing. For a lot of people in the US, they either deployed their servers on US West or on US East. So the cloud is a specific location. The cloud is usually this cloud, or we tend to think that it's this cloud because it's Northern California, but it's actually this little city called Fresno, which is not nearly as glamorous. So this is the cloud for a lot of people nowadays. And coming back to that definition, I think it's actually a really great thing to strive for, and it's something we try to do at Zeit. And it's this idea that you can deploy without worrying about where your code goes specifically. We deploy your code, we don't worry about infrastructure with just a single command. So you go to your computer, you install it with NPM, you go to any directory that holds your application code, you press Now, and the deployment is ready. So just to give you an idea of what this looks like in practice, I have a directory called My App, I press Deploying, it gives me a link right away, and this is the reason that we call it real-time deployments, because you start getting the logs of what that deployment is doing right away. This is very important because build processes in the Node.js and especially the front-end JavaScript community keep getting bigger and bigger and bigger and bigger, and sometimes there's a lot of failure when it comes to building your application. So the idea of immediately getting feedback about what's going on is a very, very important notion. We don't want to execute a black box in the sky. The next step that I run there is I give it a name, I alias it, but we're going to get into that later on. But basically, this is all there is to it. You find your directory, you type in Now, and you press Enter. The first really important notion of this is what we call immutable deployment. For those of you that are used to immutable data structures, it's this idea that you can travel back in time, and you're never modifying your data on site. This is also true for our deployments. You're never overwriting a previous deployment. You're never throwing it away unless you explicitly want to. So every time you type in Now, you get a new unique server. And this happens for you immediately. So this URL is like this. It's like the prefix will be the project's name, and then there will be some UID that's unique to your project. Because deployment is primarily about addressability. To give you a contrite example, you would never tell your boss, or maybe you wouldn't be here today, oh, I just deployed to localhost, it's ready. No, you probably want to deploy somewhere where other people can use it. So it's all about taking that code to production. And to take it to production, you also wouldn't give people these strange URLs that are immutable and have some random nonce in it. So we have this simple command that we call alias, where you take one URL and you give it an easy-to-use subdomain or even a full domain name. So this is what it looks like in practice. I take the URL that I just deployed. I give it a custom domain in this case. Notice that I also didn't worry about the other pieces of infrastructure that are usually kind of a pain to manage. So for example, SSL certificates and renewal and DNS records. All of that really doesn't matter to us because we only worry about your code, putting it in the cloud, and give it a name that's easy to use and friendly to users or customers. In terms of scale, this is actually one of the most interesting premises of this system. And the reason that we started with Node is we care a lot about elasticity of your deployments. And for your deployments to be elastic, they have to boot up and replicate very quickly. So Node was our initial platform because it satisfied this condition for a large variety of processes. When you deploy and run something in Node, it's actually very, very quick to boot up. Compare that to like initializing the Java virtual machine, and you wouldn't have this sort of like really easy scale and elasticity. So a request comes in, and we match it with one of your Now applications. If more requests come in, we match it with more containers and more Now applications. So these are actually hosted in infrastructure that's already scalable, already proven, but that you don't have to worry about, which gives this system a property of censorship resistance. So if Amazon decides to not work with you or not work with us, or there's a DMCA complaint and they shut down your website automatically or algorithmically, like some of these cloud providers do sometimes, we have a fallback. Some of these are well-known and well-understood. Some others are less tested, but we care mostly about geographical reach and latency. And the other problem that this solves is that when traffic slows down, a lot of your cloud deployments end up being overfitted. So you end up either under-provisioning, which means you crash under load, or you over-provision, and you pay a cloud provider way more than you actually need to pay them because your traffic fluctuates. And sometimes you have a certain spike in a certain geographical area that you didn't even know existed. True story. So truly elastic, yet not limited to very simple functions. So we support any service that talks over the HTTP protocol. No matter what it does, we can launch more of them, provided that you basically worry a little bit about statelessness, and boot up time is also a concern, specifically for the benefit of your users. Geographically distributed means that you're not going to have to worry about what location to pick or what region to pick. And there are some unique benefits to this. So first of all, we give you a built-in HTTP2 support, so you also don't have to worry about the capabilities of your edge proxy, as well as SSL, which is a requirement for most HTTP2 deployments. So this will give you, out of the box, a dramatic performance improvement across many different verticals. One that's specifically interesting is mobile connections. So on the way here on my Uber, I had a 2G network, and imagine if I had to establish TCP connections to 20 different host names, I would probably struggle. Or if I have to start many connections for HTTP1, it's also not ideal for connections where even one connection is very hard to establish, especially reliable connections like TCP. So mobile and real-time connections will benefit, mobile and real-time applications will benefit greatly from this built-in HTTP2 support. The other thing that we focused on is to make this platform universal. So a lot of our larger customers use Node, but not every team within their company will, over time, use Node. Maybe a certain API that they need is written in some other language, or maybe they want to deploy a modified version of Node. So we worry about universality. The first piece of manifest or like code that we support is JavaScript. So provided that there's a package JSON, you can deploy it. The second one is Docker files. So if you can encode or create a recipe of your application as a Docker file, you just press now again, and this will give you the ability to deploy a wider variety of programming languages or scripts. Or static websites. So for a lot of people, like you run a marketing campaign or you create documentation website for your project, you don't really need to necessarily have a full programming language behind it. You just want to deploy a bunch of pre-compiled HTML, or you probably just want to use our build step to compile it and build it and bundle it in the cloud. So JavaScript, the JavaScript VM, Linux binaries, and HTML are the three verticals of our focus for deployment. And like I said, it's real time because you get that feedback in real time. When you deploy a JavaScript application, we invested a lot of time making sure that you're not waiting forever for NPM install to complete, or you're not waiting forever to perhaps run tests or integration systems that are quite CPU or memory intensive. So we have a smart cache that every time you deploy, specifically if you're making a lot of changes and deploying a lot, you don't really need to refetch every package every time. So our goal, and it's a pretty extreme one, is we really want to be faster than localhost, because the reality is that computers maybe will not have the hardware capabilities that the cloud has in order to, for example, parallelize a big compilation, or your local system might be burdened by lack of memory, or your network might not be that fast when you're at a certain coffee shop. So for us, it's much better if we just share the delta of your source code, put it in the cloud, and run the build process there. And finally, something I want to emphasize is we invested a lot of time thinking about what the best models are for elasticity and for you to become more productive. So we found that microservices are very uniquely fitted to this deployment process and idea. So imagine that instead of versioning your entire API, you could deploy method updates all the time. So imagine that each API method that you have, or each schema that you have, like for example, if you're using a GraphQL backend, had its own little service that you can update on a one-per-one basis. So essentially, you can deploy updates all the time, and you're not constrained by a single monolithic process. So we think that this idea of monoliths versus microservices, at the end of the day, is somewhat of a false dichotomy. And the reason for this is that to the consumer of your services or websites, it has to look and feel like a monolith. So just to give you an example, you want to have a consistent interface, a consistent URL, and, for example, a single authentication mechanism for all your API. You don't want to have 20 different ways of accessing your data, for example. So imagine that your end goal is to have an API server that has 3 different paths. We think that the ideal approach to solving this problem is you split up the code into discrete microservices that run discrete processes that can be individually tested. But then you can deploy them individually to independently scaled services. And then all you have to do is provide the mapping. So we think that to the consumer, the API looks like a monolith. It's api.something.com. Or when you're working on a website, you don't want to, for example, deploy to different subdomains and then have users re-authenticate. There are like a lot of scenarios where the user experience increases a lot if you do everything under a single domain, for example. So you could be tempted to conflate this idea that the interface looks like a monolith with I should build a monolith. But with Now, we're working hard to make sure that you can still have the benefits of microservices where it's a very smooth experience to develop and deploy and scale. But when we proxy, we make it really easy for your end consumer interface to look like a monolith. So the user and developer experience would break otherwise, but more importantly, you could have performance problems. So like I mentioned earlier, if you're taking advantage of HTTP2 connection reusage, for example, you want all the data flow to happen over a single domain and over a single connection. So this model allows for that very elegantly. So to this end, we developed a little library that we call Micro that makes it very easy to focus on a single concern at a time. So notice that I don't deal with routing here even. So all I do is, from my module, I export a function that is defined as async. And within it, I can await a bunch of promises. So this solves two things from our perspective. So one of them is, again, you don't really need to start with a large server to which you configure every single type of middleware that any endpoint within it might require. So that's one thing. Here, you await a specific concerns that this specific microservice has. So for example, if it doesn't need to do body parsing, you don't really need to include the body function that you can await. So it increases performance by only evaluating and executing the things that are relevant to a specific endpoint or server. So that's one thing. And the other thing is, it really solves the callback hell problem, because you just need to run micro index.js, for example, for this file. And within it, we transpile on the fly. We do this very quickly. We don't have to invoke Babel or anything like that. And within it, you can manage asynchrony very, very easily. So any function that returns a promise can be awaited, and you can express your business logic very, very nicely. So I'll show you the GitHub once again, Zeit/micro. When you run the micro program, it listens on a server, and that server can be obviously rerouted and reproxied to a specific path name, for example, within your API, and that way you don't really have to worry about that monolith versus microservice dichotomy. And at the same time, you don't have to worry about writing code that's brittle. And then perhaps the most interesting benefit of this architecture is when you boot more of your microservices, they will boot up extremely quickly. Perhaps one of the most overlooked aspects of performance is you just need to load less code. Because loading code takes time in the form of interpretation time, parsing. It takes up a lot of memory once it's fully loaded by the node process. And that means that if you have a request coming in and we're scaling very quickly, you really want to make that happen very, very, very fast. So Micro is a project that we open source to sort of try to contribute to this end goal for the community. Write smaller chunks of code that have one primary concern. That is it for today. I only had 20 minutes, but we have 2 minutes and 40 seconds for questions if anyone is so inclined. Yeah. Yeah, he's asking about databases, and that's a really, really great question, because our vision is we really want to be the best at creating this glue for the cloud. Databases are emerging every single day in ways that are not very obvious. So for example, you can use the Google Spreadsheets API to host some data. Provided the data volume is not that big, for example, you would have a lot of benefits like collaboration and introspection and the ability to see your data, which a lot of databases don't actually provide very easily, an immediate front for your data. So we think that over time, databases are going to be hosted not by you, but by people that are consistently upgrading them, monitoring them, scaling them on your behalf. For example, if we apply the same model of you want to change your code and deploy a new version, if you wanted to upgrade your database in that way, you would probably have a lot of trouble, because you would have to deal with all this state, you would have to deal with all these migrations, and at the same time, you would have to deal with operational problems that come with databases. So our customers use specific databases to solve specific problems. So for example, if you're building a chat application, you can use Firebase. If you're building a CRM, you can interface with another API that's more suited for the kind of queries that you're going to make. One thing that we've seen in the marketplace is databases become more and more specific to each use case. So you use Elastic for search engines, or you use Influx for time series data, or you use specific services that don't look like databases. There's a great talk by Joel, or a great blog post by Joel Spolsky, saying that the best kind of applications are actually data structures. So if you store your data in Trello, you boot up a service on Now that makes API calls to Trello, and you're using them as your backend of storage because maybe the data structure that they deal with fits your application really well. So we're sort of trying to rethink how to best serve our customers in this way. We recently launched our secret storage solution that allows to provision API keys for your deployments. And we're working with partners on making that process of getting and obtaining and supplying the API key for a certain database to your deployment very, very quickly. So at the end of the day, it feels like you just deploy a database, but all you're doing is you're orchestrating its deployment through a third party. And we think that that's really great because it relieves you from the burdens of operational difficulties of databases that are many. Any other questions? Yeah, so for Dockerfile, we took a very hard look at the container spectrum. And one thing we found is that containers are smaller, but when you actually are building them all the time and when you're downloading them and re-uploading them, in practice, they take often like hundreds of megabytes. And if you remember about like Amazon AMIs or ISO images, those used to be like in the 600, 700 megabyte ballpark. And in practice, containers can get to that point as well. So what we do is we synchronize the contents of the Docker file, and we build the image for you in the cloud. So you really don't have to deal with registries. You don't have to deal with uploading and downloading images. And within it, you can basically write any orchestration code that you want, including code that, as an example, we purposefully made a really funny example on our blog. We wrote a microservice in COBOL, which is probably the oldest programming language that has an HTTP, let's call it a framework to be polite. But essentially, we deployed a microservice in a 60-year-old programming language, just to make the point that we are creating a universal platform and that we can give you this versatility without adding operational complexity. So you should check out our blog, zeit.co/blog, and you'll find examples of Docker files. When we announced the feature recently, we did PHP. If you really think about like PHP as a way that most people have used it, it fits this model really well because most people never cared about writing HTTP code in their PHP applications. They just wrote a bunch of PHP files that were primarily concerned with their business logic. And this is what made PHP people really productive. So Facebook.com, Box.net, a lot of really big companies are powered in some big way by PHP. So when you announce Dockerfile, we're embracing that. There are really great alternatives also to Node. We primarily think that JavaScript is here to stay because of its symmetry with the browser. One really interesting use case for now is you can build applications that are server-rendered and that have very interactive front ends. So it feels like you're doing a static hosting because you just write now and it's there and you get a link immediately. But you have the capabilities to really run anything on the back end. And also, when we took a look at like what are the primary technologies that allowed for really awesome universal JavaScript applications, we found that the NPM node modules directory can be hundreds and hundreds of megabytes of like Babel, React, Angular, jQuery dependencies. So that's another really interesting use case because with us, you just upload the source code. The build happens in the cloud. If it fails, you can even share that URL with your coworkers and say, like, look, there was a transitive dependency in NPM that just broke my life. Can you help me? And you show them the log of the build. So that's sort of it feels a little bit like unifying development, staging, and production because it's all the same system. I think there was one last question over there. And we're out of time. All right, thanks a lot. And I'll be around if you have any other questions or want to chat. Thank you.